Hey everyone, and welcome back to the deep dive. Don't forget to hit that like button and subscribe to our channel, and make sure you click that notification bell so you don't miss out on any future episodes. Okay, so tonight we're diving into those streaks of light, those celestial wanderers, uh, the comets, meteoroids, meteors, and meteorites.
Yeah, it's a topic that bridges the gap, so to speak, between everyday wonder and serious scientific study. Something that just, sparks the imagination. Everyone from, astronomers to even like UPSC aspirants and senior school students who are, just starting their exploration of the universe.
Exactly. And speaking of exploring, our journey tonight is going to take us through Minor Planet Part 2.pdf, which is a fascinating resource that's going to help us unpack the intricacies of these objects. Think of it as your crash course in all things comets, meteoroids, meteors, and meteorites.
Who knows? Maybe you can even impress your friends with some cool facts about, those shooting stars everybody loves to wish on.
Okay, so let's start with those elusive cosmic travelers, those comets. They're like those rare celestial guests that grace our skies every, few years or centuries.
Yeah.
Putting on a spectacular show with their glowing tails. What exactly are these icy wanderers? And where do they come from?
So imagine a giant, dirty snowball just hurtling through space. And that's essentially what a comet is. They're composed of ice, dust, and rock. They're remnants from the early formation of our solar system. And what makes them really captivating is their elliptical orbit around the sun.
So that elliptical orbit's key, right? That's what brings them close to the sun, where the real magic happens.
Precisely. As a comet gets closer to the sun, the heat causes the ice to vaporize, creating a glowing cloud around the nucleus. We call that the coma. And then as the comet gets even closer, the solar wind, it pushes the gas and dust away from the coma, forming those magnificent tails we, associate with comets.
Wait, I thought there were two tails. Am I imagining things?
No, you're absolutely right. Comets actually have two tails. An ion tail, which is made of ionized gas and points directly away from the sun, and a dust tail, which curves along the comet's path. It's like a cosmic double feature, a really breathtaking sight.
Yeah, it's like a cosmic ballet with the sun playing the role of the spotlight.
Yeah.
But let's back up a bit. Let's talk about the different types of comets. I remember hearing about like short period comets and long period comets. What's the difference between them?
So the difference, it lies in their origins and consequently their orbital periods. Short period comets, like the famous Halley's Comet, they originate from the Kuiper Belt. That's a region beyond Neptune, teeming with icy bodies. These comets take less than 200 years to orbit the sun.
So Halley's Comet, the one that visits us every 76 years, that's a short period comet.
Right.
Okay, that makes sense. But what about the comets that take like thousands of years to complete a single orbit? Where do those come from?
Those are the long period comets, and they hail from a much more distant and mysterious region called the Oort cloud. And it's thought to be a vast spherical shell of icy objects that surrounds our solar system, way beyond the planets that we know and love.
The Oort cloud. Wow, that sounds like something straight out of science fiction. It's incredible to think that there's this massive reservoir of potential comets out there just waiting to make their grand entrance into the inner solar system.
Yeah, it's a reminder that our solar system is a vast and dynamic place with objects constantly, moving and interacting in ways we're only beginning to understand.
Okay, so we've got these icy comets cruising around, putting on a spectacular show, when they get close to the sun. But what about those smaller bits of space rock we hear about?
Yeah.
The ones that sometimes make the news for, like, landing in someone's backyard. Those are meteoroids, right?
Mhm. Exactly. Meteoroids are, they're like the cosmic pebbles of our solar system, ranging in size from tiny grains of dust to objects several meters in diameter. And just like comets, they can be made of rock, metal, or a combination of both.
So where do these meteoroids come from? Are they like little pieces of planets that broke off, or what?
Think of them more as leftovers from the formation of the solar system or debris from collisions between asteroids and comets. Some even originate from impacts on the moon and Mars, which is pretty mind-blowing when you think about it.
So we're essentially surrounded by these tiny pieces of space rock constantly zipping past us. It's kind of like a cosmic shooting gallery out there. But what happens when one of these meteoroids decides to pay Earth a visit?
That's when things get really interesting. When a meteoroid enters Earth's atmosphere at high speed, it experiences intense friction with the air molecules. And this friction causes the meteoroid to heat up and glow, creating a streak of light that we call a meteor or more commonly a shooting star.
Oh, so that shooting star we see streaking across the sky is actually a meteoroid burning up in the atmosphere.
Precisely. And the size of the meteoroid determines how bright the meteor appears. Sometimes we get these incredibly bright meteors called fireballs or bolides, which can light up the night sky, like a celestial firework.
So the next time I see a shooting star and make a wish, I'll know I'm actually witnessing a piece of space rock meeting its fiery end in our atmosphere. That's a pretty cool way to think about it. But what happens if a meteoroid survives its fiery plunge and actually makes it to the ground?
Those lucky survivors earn the distinguished title of meteorite. They're tangible pieces of extraterrestrial material that have, literally fallen from space, offering us a glimpse into the composition and history of other celestial bodies.
So imagine holding a piece of space in your hand. That's what a meteorite is. It's like having a tiny piece of the cosmos right here on Earth. And just like meteoroids, meteors come in different varieties, right?
Absolutely. We classify them based on their composition. Iron meteorites, and stony iron meteorites, each with their own unique characteristics and origin story.
So iron meteorites, and stony iron meteorites. It's like a cosmic rock collection. But before we delve into the specifics of each type, let's take a step back and make sure we're clear on the difference between meteoroids, meteors, and meteorites. It can get a little confusing.
It's all about location and what's happening to the space rock, basically. A meteoroid is simply a piece of space rock, out in space, minding its own business. A meteor is the streak of light we see when a meteoroid enters Earth's atmosphere and burns up. And a meteorite is what's left of a meteoroid if it survives that fiery journey and actually lands on Earth.
Okay, so meteoroid in space, meteor in the atmosphere, and meteorite on the ground. Got it. But what about those extra bright meteors we talked about earlier? Those fireballs, the ones that light up the sky, like a celestial firework display. What causes those?
They're caused by larger meteoroids entering the atmosphere. Think of it as like a supersized meteor, burning brighter and lasting longer than its smaller counterparts. And they're not just visually impressive, they're also scientifically valuable.
Scientifically valuable. How so?
By studying fireballs, scientists can gather crucial information about the composition and speed of these larger space rocks. It's like having a front row seat to a cosmic fireworks show while simultaneously conducting scientific research.
That's amazing. So we've got comets, meteoroids, meteors, and meteorites, a whole cosmic cast of characters, and each one tells us a story about the formation and evolution of our solar system. But there's so much more to explore. Before we delve deeper into this fascinating world of meteorites, let's take a quick break. We'll be right back with more cosmic insights on The Deep Dive. Welcome back to The Deep Dive. Before we jump back into those fiery fireballs, let's revisit those icy comets for a moment. We were talking about their incredible journeys around the sun and those spectacular tails that trail behind them. What exactly happens when a comet gets close to the sun, that creates such a dramatic display?
Well, it's a cosmic transformation fueled by the sun's intense heat. As a comet approaches the sun, the icy nucleus starts to vaporize, releasing a mixture of gas and dust. This forms a glowing cloud around the comet, known as the coma. You can think of it as a comet's temporary atmosphere.
So the coma is like a comet's way of announcing its arrival, like a cosmic hello as it gets closer to the sun. And it can get pretty large too, right?
Absolutely. The coma can expand to thousands of kilometers in size, dwarfing the comet's nucleus. And as the comet gets even closer to the sun, things get even more dramatic. The solar wind, the radiation pressure from the sun, it starts to push the gas and dust away from the coma, creating those iconic tails that we associate with comets.
Right. It's like a cosmic windsock with the sun's energy shaping and directing those tails. And remember, we talked about how there are actually two tails.
Mm-hmm.
The ion tail, made of ionized gas, and the dust tail, which curves along the comet's path.
Exactly. The ion tail, with its bluish hue, points directly away from the sun, almost like a cosmic finger pointing the way. And the dust tail, on the other hand, is usually white or yellowish and follows the comet's curved trajectory, creating a breathtaking celestial spectacle.
It's incredible to imagine these icy objects traveling through space for millennia, leaving behind such a dramatic trail of gas and dust. It makes you wonder, like, how many comets are out there just silently cruising through the depths of space, waiting for their moment to shine. But let's shift gears for a moment and talk about those smaller space rocks, the meteoroids. We discussed how they can come from comets, asteroids, or even impacts on other celestial bodies. But
Sure.
how do scientists actually study these tiny elusive objects? It's not like they can just set up a telescope and wait for a meteoroid to fly by, right?
That's a great question. Studying meteoroids can be tricky, but scientists have developed some clever techniques. One way is through meteor showers.
Ah, meteor showers.
Yeah.
Those magical nights when the sky is filled with shooting stars, all seeming to originate from a single point in the sky.
Precisely. Meteor showers occur when the Earth passes through a stream of debris left behind by a comet. As these particles enter the atmosphere, they burn up, creating those beautiful streaks of light that we call meteors.
So meteor showers are like a cosmic light show, orchestrated by comets.
Yeah.
It's amazing to think that we can witness these events here on Earth, these tiny pieces of a comet's journey, lighting up our night sky.
Yeah, it's a reminder that we're connected to these celestial objects in ways we might not always realize. And by studying meteor showers, scientists can glean valuable information about the composition and distribution of meteoroids in space.
So how do they do that? Do they use like special telescopes or equipment to analyze those fleeting streaks of light?
Well, they use a variety of techniques, including ground-based observations, radar systems, and even spacecraft missions. For instance, NASA has a spacecraft called the Parker Solar Probe, originally designed to study the sun's outer atmosphere, but it also carries instruments to detect and analyze dust particles, including those from comets and asteroids.
So we're sending probes to the sun and using them to study like tiny particles from comets and asteroids.
Yeah.
That's pretty impressive. It seems like we're constantly finding new ways to explore and understand our cosmic neighborhood.
Yeah, technology is opening up incredible opportunities for scientific discovery, allowing us to study these celestial objects in ways we couldn't have imagined just a few decades ago. But let's not forget about those meteoroids that make it all the way to Earth. The meteorites.
Right, meteorites. They're like those rare treasures from space, offering a tangible connection to the cosmos. And they can tell us so much about the history of our solar system, can't they?
Absolutely. Meteorites are like time capsules from space, preserving information about the early solar system and the conditions on other celestial bodies. By studying their composition, scientists can glean insights into the formation of planets, the building blocks of life, and even the potential for life beyond Earth.
It's like holding a piece of another world in your hand. Speaking of different worlds, let's break down the main types of meteorites because I know they come in a variety of forms, each with its own story to tell.
You're right. The three main types are iron meteorites, stony meteorites, and stony iron meteorites. Iron meteorites, as their name suggests, are mostly composed of iron and nickel. They're thought to come from the cores of asteroids that were shattered in collisions, giving us a glimpse into the heart of these ancient celestial bodies.
So iron meteorites are like pieces of an asteroid's heart, forged in the intense heat and pressure of its core. That's pretty amazing.
Yeah.
What about stony meteorites? They sound a bit more familiar.
Yeah, stony meteorites are the most common type, and they're composed of rocky materials similar to what we find on Earth. They're thought to come from the outer layers of asteroids, giving us a glimpse into the diverse composition of these space rocks.
So they're like little pieces of an asteroid surface, carrying with them the history of its journey through space. And what about those rare stony iron meteorites? Where do they fit into the picture?
Well, stony iron meteorites are a fascinating mix of both iron and stony material. They're relatively rare and are thought to come from the boundary between the core and the mantle of differentiated asteroids. It's like finding a piece of the transition zone between an asteroid's heart and its outer shell.
It's incredible to think about these different types of meteorites, each are originating from a specific part of an asteroid and carrying with them a unique story about its formation and evolution. But let's not forget about those dramatic impact craters we talked about earlier, like the Lonar crater in India and the Chicxulub crater in Mexico. Those were formed by much larger objects than your typical meteorite, right?
You're absolutely right. Those massive craters were formed by by asteroids, much larger rocky bodies that orbit the sun, mainly found in the asteroid belt between Mars and Jupiter.
So asteroids are like the big brothers of meteoroids.
Yeah.
And they can pack a serious punch when they collide with a planet. The Chicxulub impact, for example, is believed to have caused the mass extinction event that wiped out the dinosaurs about 66 million years ago. It's a stark reminder of the power of these celestial objects and the impact they can have on the course of life on Earth.
It's a humbling reminder that we're part of a vast and dynamic solar system, where collisions are a natural part of the cosmic dance. But amidst these cosmic collisions, there's also a sense of wonder and beauty.
Absolutely. Think about those meteor showers, those celestial displays that have captivated humans for centuries. They remind us that we're part of something much, much larger than ourselves, a universe filled with mystery and awe.
It's a perspective that can inspire us to explore, to learn more about these celestial objects and the secrets they hold. Speaking of secrets, did you know that scientists have discovered organic molecules, the building blocks of life, in meteorites?
No.
This discovery has fueled speculation that life on Earth may have originated from space, carried here by meteorites billions of years ago.
Yeah.
It's a mind-boggling concept that challenges our understanding of the origins of life itself.
That's incredible. So not only do meteorites provide us with clues about the formation of our solar system, but they might also hold the key to understanding the origins of life on Earth. And who knows what other secrets they might hold, just waiting to be unlocked by scientific inquiry.
It's a reminder that we're still at the beginning of our journey of cosmic discovery, and there's so much more to learn about these fascinating objects. But before we delve deeper into the scientific methods used to study meteorites and their implications for understanding life in the universe, let's take a moment to appreciate the beauty and wonder of these celestial travelers.
You're right. Whether it's the ethereal glow of a comet's tail, the fiery streak of a meteor across the night sky, or the tangible connection to space we get from holding a meteorite, these objects have a way of capturing our imagination and reminding us of our place in the vast cosmos. And with that thought in mind, we'll take a quick break. Join us for the final part of our deep dive as we explore the ongoing scientific quest to unlock the secrets of these celestial wonders. Welcome back to the deep dive. We've journeyed from the icy depths of the Oort cloud to the fiery plunge of meteoroids through Earth's atmosphere, and even pondered the mysteries of life hidden within meteorites.
Yeah, and in this final part, we're gonna kind of shift our focus from the what to the how. How do scientists actually study these celestial objects? What tools and techniques do they use to unlock the secrets hidden within comets, meteoroids, and meteorites?
Right. It's like being a cosmic detective, piecing together, clues from across vast distances and timescales. So what's in the cosmic detective's toolkit?
Well, one of the most essential tools is of course the telescope. From ground-based observatories to space-based telescopes like Hubble and James Webb, these instruments allow us to peer deep into space, capturing light from distant comets and tracking the trajectories of meteoroids.
It's incredible to think about how far telescope technology has come, allowing us to see, objects billions of light years away. But telescopes aren't the only tool in the box, right?
No, not at all. Spectroscopy plays a crucial role in analyzing the light from these objects, revealing their chemical composition and physical properties. By studying the light emitted or absorbed by, comets, meteoroids, and meteorites, scientists can determine what they're made of, their temperature, and even their speed.
So it's like using light as a cosmic fingerprint, revealing the unique identity of each object. And speaking of fingerprints, what about those meteorites that actually land on Earth? What kinds of analyses are done on those?
Meteorites provide a unique opportunity for hands-on analysis. Scientists can study their physical structure, their mineral composition, and even their isotopic ratios to understand their origins and the conditions they've been exposed to over billions of years.
It's like having a piece of another world, delivered right to our doorstep. And with advanced imaging techniques, scientists can peer deep inside meteorites, revealing their internal structure and the stories they hold.
Exactly. And sometimes meteorites contain, microscopic grains of dust or even tiny diamonds that predate our solar system, offering clues about the events that led to its formation. It's like finding a cosmic time capsule within a time capsule.
That's mind-boggling. And what about those larger impacts, the ones that leave behind massive craters like the Lonar crater in India or the Chicxulub crater in Mexico? How do scientists study those?
Studying impact craters involves a combination of geological field work, remote sensing techniques, and computer modeling.
Hmm.
Scientists analyze the crater's shape, the size, and the distribution of ejected material to understand the impact's energy and the trajectory of the impactor.
It's like reconstructing a cosmic crime scene, figuring out the who, what, and when of the impact event. And these studies can tell us a lot about the history of Earth and the role of impacts in shaping our planet.
Absolutely. Impact events have played a significant role in Earth's geological and biological evolution, from the formation of continents to the extinction of dinosaurs.
Hmm.
Studying these events, it helps us understand the forces that have shaped our world and the potential threats from future impacts.
Right. It's a reminder that we live on a dynamic planet, constantly interacting with the cosmos,
Yeah.
and with each new discovery, with each advance in technology, our understanding of these celestial objects and the universe they inhabit continues to grow.
It's a journey of exploration that's driven by human curiosity, a
Yeah.
thirst for knowledge, and a sense of wonder about our place in the vast cosmos.
And that sense of wonder is what makes this topic so
Yeah.
captivating, whether you're a UPSC aspirant, a senior school student, or simply someone with a curious mind, gazing up at the night sky.
So the next time you see a shooting star, streaking across the sky, or hear about a new meteorite discovery, remember that you're witnessing a piece of a grand cosmic story, a story that scientists are still working to unravel.
And who knows, maybe one day you'll be the one, making those discoveries, contributing to our understanding of these fascinating celestial wanderers.
Yeah. That's the beauty of science. It's an ongoing journey of discovery,
Yeah.
and everyone has the potential to contribute.
Well said. And that's a wrap for our deep dive into the world of comets, meteoroids, meteors, and meteorites. We hope you've enjoyed the journey and learned something new along the way.
Until next time, keep looking up at the sky, keep asking questions, and keep exploring the wonders of our universe.
And remember, if you enjoyed this deep dive, don't forget to hit that like button, subscribe to our channel, and click the notification bell so you don't miss an episode of the deep dive. We'll see you next time for another adventure into the unknown.